All right, hopefully for number one, you realize that you can redraw this problem to where it looks a little bit better. Technically, this is a projectile motion problem. Whoops, I don't need that. Undo. I think it just got like uncalibrated for me.
Is that the answer?
What was the other one?
Yeah. Need to calibrate. Hold on.
Liar.
All right, let's look at number one again. Sorry, I think now the thing is not going to screw up. So hopefully with number one, what you realize is that you actually have, this is still not calibrated at all. This is actually a projectile motion problem. You can redraw it, like if you flip it basically upside down, you can make it look like this. And now you've got like some x velocity, right? In mine it was 8.7 meters per second. And it's telling you the acceleration downwards, if you want to think of it that way. Doesn't really change anything. Mine was 4.1 meters per second squared.
What number is it?
This is number one. It collides with this wall on this side sometime later, right? And it's asking, what is its speed when it hits this opposing wall? If you can kind of picture this, basically, like, if you were to zoom in on this as many times as you could and get down to like the microsecond that it hits the wall, basically it's impacting the wall at an angle. Okay, so what you have is a right triangle, what we can simplify it down to. Okay, so if I want to figure out what the velocity is here, I'm going to find Vfx and Vfy, and then do what with them?
You get the.
Is that how your graph look like?
Well, no, I flipped it because I was saying this is actually projectile motion. Acceleration in one dimension, constant velocity in the other. So I was just drawing it so it looks like what we're used to. Basically what you're going to have is, like I said, a triangle right here. You're going to have an x velocity and a y velocity, but we want the true velocity of the object, so what would we solve for? The resultant, okay? So you'd use these two things to solve for the resultant. So all we have to do is figure out what to do with those two things, or how we're going to find those two things. The one in the x direction is probably the easiest to start with. Right, so this would be, I don't know. Okay, in the x direction, what is the velocity in the x direction when it hits the wall?
It's constant.
It's constant, so it's whatever the problem gives you, right? So this is a constant. You could just look in the problem and find out, Kevin, seriously.
Oh, did I do that?
Yeah, you hit it again.
Sorry.
You probably shouldn't sit there. So you just look in the problem to figure out what the x velocity is. We can also use the x velocity to help us find out another thing. Right, time. So we can say, not this, we can say that velocity is equal to delta x over delta t. Right? If you know what your velocity is here, then you can say that time is equal to delta x divided by your velocity. And delta x is given in everyone's problem. Right? So you can solve for time this way, get some value for time. And my problem, what was it? I don't think I even worked this one out because it's too easy. It should be easy. It was like 2.114 seconds or something like that. Right? That's the amount of time the projectile spends moving. So then you can go over to your change in y formula. Wait. No, it's actually even easier than that. You don't even have to do change in y. Yeah, you're right. You don't have to do change in y. Okay, this isn't going way to crap on me. There you go. Okay, so you don't even have to do your change in y formula. Because the acceleration is constant, in the y direction, you can actually use this formula. You can use a equals this. Wait. Yeah, because you don't have an initial velocity in the y direction, right? So this really is Vf if you want to think about it that way. All right, so you'd say that Vf is equal to at. So you take the acceleration that's given and multiply by the time you found. Now you have those two values, so you could say the true final velocity is equal to the square root of Vx final squared plus Vy final squared. Because what we have is a triangle. You've got two an x and a y velocity, but we want to find the resultant to find out what speed it's actually moving. Yeah, it goes.
What is that?
It's Vx final squared plus Vy final squared. Sorry, my pen is.
Wait. So we just found Vx final. Right?
We found Vx final is constant. You don't have to solve that at all. Vy final is what we found here. By using the time, so we know like it's moving this fast x. We know how far it moves x. So we can figure out how long it takes for it to move that x distance. How long it takes for it to move the x distance is how long it's going to take for it to move the y distance.
I got 10.86.
Use the time
I got
depending
something
on.
like that. Hey, I'm YOLOing you right now.
You might need to, but I mean, I said you might be able to, but
I got
I wouldn't.
8.771.
This is a lot easier.
Oh, I just used that one and got it wrong.
This one?
No, the one.
The-
I
I
got
don't know.
both of them wrong.
I don't think.
This one just now.
Yeah.
And still got it
Oh
wrong.
my
This should give you the right answer. Did you do this? That's what you have to do.
I know.
Yeah.